For radical equations, we have a few steps that we need to follow, and this first step's really important, and I don't have it on yours. So that's the only thing you need to have written down, changed on yours. Set the inside of even roots greater than or equal to 0. Can somebody raise their hand and tell me why? Set the inside of even roots greater than or equal to 0.
Because number 1 says so?
No. Anthony? You don't want to have imaginary solutions here, right? So if it's under an even root, we need to set it greater than or equal to 0, so we're not taking the square root of a negative number. I did remove that because Sure. All right, so it's really basic. We want to get rid of the radical by performing the inverse. On yours, I said get it to one side. But I kind of looked at my steps, and I tried to genericize the steps because you guys, and on average, students like steps they can follow. But it was a little too constricting, and that second example is going to show why. Because moving all the, if you have radical expressions, you should have them on both sides if there are two of them. You should have them on both sides if there are two of them. Okay? If you're ever getting rid of the radicals or the roots, and things get bigger, that's okay if they get bigger once. But if they get bigger in a way where it looks like they'll just keep getting bigger, you want to stop and you did something a little wrong. And we'll see what that looks like in a little bit. So this is very simple. What kind of root is this? A square root. So how do we get rid of a square root? You square it. Now, here's the thing. If the square root, I want you guys to see, so do not write this down even a little bit. Okay? Do not write this down even a little bit. I want to show you what I mean where you'll want to get just the square root on the side by itself if possible. Okay? Just a square root on the side by itself. If I square both sides, I want you guys to see, I'm going sloppy for a reason. This would be the square root of x plus 7 times the square root of x plus 7, sorry, plus 5, right? It's just really sloppy. That would get rid of it. But then that would bring it back. It's not really getting rid of it. If I get just the square root on one side by itself, I can. So if possible, that's kind of the asterisk, if possible, get the square root on the side by itself. So I subtract 5 from both sides. This you can write down. I subtract 5 from both sides, and now I've got just the square root on one side and not square root on the other. That's a good thing. Ooh, off to the side, either left or right side, depending on how you guys wrote this out. Make sure what's underneath the square root? X plus 7 has to be greater than or equal to 0. So whatever values for x we get, they better be greater than or equal to negative 7. Because if I get a value less than negative 7, or sorry, less than 7, no, less than negative 7, I was right. If I get a value less than negative 7, I'll end up with an imaginary solution. I can't have that. So if I get something, this is saying no, I can't. This is kind of an excluded value statement. This is an excluded value statement. So anyways, I've got the square root on one side and the non-square root on the other. Yes?
So for that, just
It's for us to know when we get to the answer.
So we don't need to write that down as long as we just know that.
Yeah, because I'm going to ask you on these to look for extraneous solutions by substituting back in anyway. So more than likely, but it's good to know. So now I can square both sides. And I get x minus 5 squared. Whoop. X minus 5 times x minus 5 is x squared minus 10x plus 25 after all the distribution and combining like terms. And the square and the square root cancel. All right? Now, if we're lucky, this factors. If we're not lucky, it doesn't. Does anything multiply to 18 and add to 11? 9 and 2. I will slow down, Destiny. I apologize. Thank you for bringing it to my attention. "45-second pause. Maybe a minute." My wife's subbing today, and she stole my soda. I want my soda really bad now. She drank it already. Miss Anna Porta? Destiny, do you have any questions about what we did? Cool. Victoria? No? Sarah? Sound good? What's up?
Why is it greater than or equal to? X plus 7 greater than or equal to?
Because if I had, like, let's say if x was -8, right, which is less than -7, I'd get -8 plus 7, and I'd end up with the square root of -1. And I can't take the square root of a negative, not when I'm dealing with real numbers. So that means whatever's under my even root, so if it's a square root, a fourth root, a sixth root, eighth root, right, I want to set that value greater than or equal to 0. And I say those are the numbers I can't have. Okay? You can have odd roots. You can take negative numbers under odd roots all day, every day. Nope, you don't even do it. You don't even do it. Indigo asked, what about odd roots? Indigo asked, what about odd roots? Odd roots, you don't do this step at all. Because I can take, what is the cube root of -8? 2. -2. The cube root of -8 is negative. I can take the cube root of negatives, right? I can take the cube root of positives. So I don't have excluded values with negative roots. With odd roots, I mean. All right. So therefore, my two values are x equals 9 and x equals 2. Are both of those greater than or equal to -7?
Yes.
Yes. So those are probably both my answers. I should double check. We need to do a double check. Oh, it's hardly ever that I ask for those of Maya. Okay. So let's go ahead. So 9 equals the square root of 9 plus 7 plus 5. That's, if you, I mean, at that point, you guys can do it in your head, or you can or can't, okay? 9 equals the square root of 16 plus 5, which is 9 is 4 plus 5, that's 1. So 9 is a solution. Okay? And then we double check 2. 2 equals the square root of 2 plus 7 plus 5. 2 is equal to the square root of 9 plus 5. 2 is equal to 3 plus 5.
No.
2 didn't work.
So what happens if neither of them are right?
No solutions. Wait a minute. Hold on here. Just a second. Something fishy going on.
Mr. Bates,
Yeah.
did you ever see Zombieland 2 yet?
I have not seen Zombieland 2. Is it out?
You want to go together and see it?
Sure. Not even a little. Sorry, man.
First big time.
I could tell you guys a story back from my second year teaching here. So there was this.
Can we clarify? You do not want to go together.
We will not go together. We will not. Okay. So, funny story. There was a student that I had here. This was, so you guys can refresh my memory. When episode 3 came out, Revenge of the Sith, what year was that? Anybody remember offhand? It was not that far back.
I think it was 04.
I think it was 2008.
2008, somewhere. Okay.
Well, it was the prequels.
Okay. Oh, not Revenge of the Mummy. So, 2005, so it must not have been Revenge of the Sith. It would not have been that, because that was, yeah, I don't have a Band-Aid, no. So, 2005. It was not that then. It was, maybe it was Rogue One. It was something. It was some.
One would make sense because that came out like 2017.
Wouldn't have been Rogue One either then. So I can't recall. I can't recall what it was. It would have been right around whatever main Star Wars movie came out around 2009, 2010. So anyhow, doesn't really matter. There was a student that went here, and he was similar to you in attitude, and to you, Lucas. And so, and he would say, "Hey, Mr. Bates, want to go see?" And then you want to go see that Star Wars movie together? Yep, sure, absolutely. And it was, "Hey, Mr. Bates, we're gonna go see that, right?" Yep. And it was like, "Oh, where are you going? What time?" I'm like, "Oh, I'm going to the opening day showing, the midnight showing at the Edwards Theater in whatever you call it, off 4th Street, not Victoria Gardens, but the mall. What's the mall? Ontario Mills Mall. Ontario Mills Mall, right? Running joke. Yeah, ha 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 ha. So the night of, I'm in line like around 8 p.m. Waiting for the doors to open, and with all the other nerds, and I get a phone call from Miss Springer. That kid's missing. And everybody says that he was going to go with you to the movies tonight. I'm not even lying. And I'm like, no, that was a big joke. Well, he's not home right now, and you're the only one he's ever said he's going to be seeing tonight. And it was, no.
Was he at the movie?
No. Yes, I went to the movie.
Did you kidnap him and see this is all a lie and you didn't go to the movie and he's hidden in the lake somewhere?
No.
Mr. Bates.
That student has since graduated, been married, divorced, has had a child, entered the military, has left the military, and is now serving as a law enforcement officer. So, don't worry. No, that night in particular, he had decided to drive off into the middle of nowhere with his girlfriend and make nookie together. So, but unfortunately, no, in no way, shape, or form will I ever joke. No, we are not, nor shall we ever go to the movies together. And so,
Yeah, the audience just caught all of that.
All of YouTube, like, Mr. Bates.
right?
Got evidence now. This boy's been missing forever.
It's something that I can look back on and think that was funny because nothing really bad happened. I'm not going to tell you that.
He's gonna reply on the video. Oh, hey, Mr. Bates, it's me.
All right.
Mr. Bates, can you go see the new Star Wars movie?
So, guys, these ones, just to warn you, start in the upper left corner or something on this next one. It will be longer. Anthony, we're back to it, so I might want to wake up. Oh, there he is. Okay. Guys, if you have a square root, if you have 2 square roots or 2 even or whatever, 2 roots, have 1 on each side. Keep it that way. Do not move them both to the same side. You will make your problem longer. Now, this one's going to be a longer problem. Warning ahead of time. Okay? So write a little smaller and take up a little less room. So I'm going to square both sides. Okay. I'm going to rewrite it too on the upper left, okay? So. Squaring both sides. Okay. All right, Anthony, to keep you engaged, the square and the square root, what happens on the left side? They cancel. So I just get x plus 10. Now on this side, I'm going to go ahead and write it twice so we can see that it's going to distribute. Okay. I want to make sure there are no errors here, so I'm not just going to distribute it in my head. Sara, you are just trying to be a disruption in class with your sneezing. Yes, ma'am. Have you? It's Monday.
I feel that.
Okay. Looks like the pencils have stopped. So on the On the right side, I'm going to distribute, okay? 5 times 5, 25. Make sure you guys are writing as I go, okay? 5 times that mess, okay? Negative square root 3 minus x is minus 5 square root 3 minus x. Do it again. Minus 5 square root 3 minus x. And then here's where you need to make sure you're paying attention. Negative square root 3 minus x times negative square root 3 minus x is positive 3 minus x. I really don't need those parentheses, I suppose, okay? Because the square root 3 minus x times square root 3 minus x, the square root cancels, okay? And the negative times the negative makes a positive. So, and then the x plus 10 is still hanging out on the left. Yes, Aaron, I'm going to try to get everything that's not a square root onto the left-hand side. So, well, that is a form of combined line-like terms. I'm going to pause for a second, make sure we understand what I'm doing to get everything onto the left-hand side.
What I was asking was, are we able to combine like terms with the negative 5 to the square root of?
Here we are. X plus x, 2x. 10 minus 3 minus 25, negative 18. Now, right here, as Aaron was asking, right here, guys, that combines, that's going to be equals negative 10 square root 3 minus x. Right, because I've got 5 3 minus x's and then another 5 3 minus square root. I have 10 of them, yeah. Yes, now I have to square it again. Huh? We could divide by negative 10. It's what I would rather do though, Amaya, just to make sure, is I'm actually going to divide by a negative, just the negative. If these both divided by 10, I'd do it. But they all divide by 2. Let's divide everything by negative 2, just to simplify it. No, it's fine. It'll make our numbers nicer. Now, if you guys, if you've got like a quick like shortcut, maybe if you want to say it. If you've got something minus something and you divide by a negative, they just swap and stay minus. They just swap and stay minus. So it'll be 18 minus 2x. If I just divided by negative, instead of 2x minus 18, it would become 18 minus 2x. So they just change signs, right? But since I'm dividing by 2. Because we're about to square both sides, and do we really want to do 18 squared, or would you rather do 9 squared? So I'm good. But if we did divide it by 5, we'd be doing like 9/5 squared. That's not a reason to hit somebody. Mr. McCord, do you deny this? Okay, square both sides. I'm going to have to do my double check, but not too much more to solving it. Yeah. As a matter of fact, Destiny, it looks like you're getting to the bottom of your page, yeah?
Yeah, but only on one side.
On one side, so I'll move up so it'll match yours, so this will be going to the middle now. Middle. So I squared 9 minus x, I get 81 minus 18x plus x squared. 5 squared is 25, and the square and the square root cancel, and I get 3 minus x. Any questions on what I've done so far? Jada? No? Aiden? No? Watkins? Tyrell? Tyrell's got this so much that his pencil tip is moving over to Wyatt's paper. Okay. Yes. Jada, I already asked you if you're all right, and you said yes. Yeah, sure. Let's distribute, and we'll do what Jada wants to do. Jada doesn't like x squared at the end. Okay. So I distributed, and Jada wanted the x squared up front. She said, Mr. Bates, I need my polynomials in descending order by power. Yeah. Okay. Let's get it equal to 0. Now, if we're lucky, this factors. Oh, it's almost like Mr. Bates does these examples by design. Crazy. So, Lucas, if you wouldn't mind factoring that for me.
6 and 1.
6 and 1. Okay. You say what every time?
Do you have tutoring tomorrow?
Yes.
I am gonna go.
All right.
Mr. Bates,
Yes.
do you have tutoring tomorrow?
No, not for you.
Do you have tutoring for me, Mr. Bates?
So let's do this.
Wow.
He's like, at this point, I give up.
No. Never. I don't give up. I don't give up. I don't give up. So, let's do this the Lucas mental way really quick. Right here, x has got to be greater than or equal to negative 10. They are. They are. And here, x has got to be greater than or equal to 3. They're not.
So it can't work.
Neither of them work. Okay? So right here,
You said x has to be greater than or
yeah.
equal to.
So let's go if we were doing this for Destiny's third column. Okay? Destiny, let's do our excluded values on the right-hand side. Guys, focus, please. You're losing it. We have two things, excluded values of the two things underneath our square root from the beginning. X plus 10 must be greater than or equal to 0, which means any x values we get better be greater than or equal to negative 10. Those are both greater than or equal to negative 10. That's good. Here, add x to both sides. Okay? And we're going to get 3 is greater than or equal to x, which is the same thing as saying x. Ooh, actually, this means x is less than or equal to 3. That's, so they both could work. We're going to have to double check them. We're going to have to double check them. These conditions must be met. These conditions must be met. Those two numbers, those are both greater than or equal to negative 10 and less than or equal to 3. So we need to check negative 6 and negative 1 in our original equation to see if they work. So let's do the double check. Okay. I'm checking negative 6. I'm checking negative 6. I plug negative 6 substituted into my original equation. So I have negative 6 plus 10. Guys, let's make the double check kind of go quick here. What's negative 6 plus 10? What's the square root of 4? Okay, so I get 2 is equal to 5 minus. Okay. Okay, 5 minus. 3 minus negative 6 is positive 9. Square root of 9. 5 minus 3, 2. Okay, so this checks out. Sorry, that one checks out. Let's try negative 1. Yep. Squeezed it. Square root of 9? 3. 5 minus square root of 4? 2. Those both check out, so those are both solutions. We're good. We're good. You have to do the double check. I'm not asking for massive amounts of work on the double check. However much you could do in your head.
What if you can do it, like for that one, that's
For the double check, if you could do it all in your head, I'm okay with that.
because like those ones they're smaller numbers.
Right.
So like if it's like fractions and stuff, obviously.
You still feeling good?
Yes. Finally.
What's up? What are you guys talking about? Discount double check? What's discount double check? What? No, I'm good. Okay. The reason why the answer is no is because we only have one more example and we've got lots of time. So I'm getting this lesson done today.
Well, what about the
Cube both sides. That's all. I already did it a few times. Nope. All right, folks, inequalities. They work the same way as the radical equations. When we go to solve, we square or cube or whatever we need to do to both sides. If working with even roots, make sure we set the value underneath the square root greater than or equal to 0, just like the other one. Values from 1 and 2 produce test points. So those are like the rational inequalities. This is like the rational inequalities where we're checking everything between. Okay? Oh. 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 Okay. First test point. Okay. 4x plus 5 must be greater than or equal to 0. So this was a single variable equation, Destiny. This is not. Remember, whatever's under the even root has to be greater than or equal to 0. Whatever's under the even root has to be greater than or equal to 0. Because we can't take the square root of a negative.
Are we gonna need a lot of room for this?
Yeah, a little bit.
Oh my gosh.
A little bit. Not crazy. Sada, how do I get rid of the square root? Tylee, how do I get rid of the square root? Square it. If it were an odd root, we wouldn't do that. We wouldn't just set. Yeah, we just set it equal to. Just set it equal to. Correct. She said if it was an odd root, since we wouldn't make greater than or equal to, we could just set it equal to find the test point. But I believe on the inequality ones, I just gave you square roots anyways, or even roots. Yeah. No, on the inequalities. Yeah.
Wait. So since this is inequalities, I still have to do the less than or equal to 0, right?
Yeah, greater than or equal to. Yeah. Okay. All right, guys. Albert, Wyatt, Tylee, thank you. So I'm squaring both sides. I get 4x plus 5. We're getting test points, so actually we're not even checking to see the inequality is meaningless right now. So I'm getting a test point. So it's equal to 100. I mean 20, wrong way. Am I right there? No, I'm wrong. Keep on doing it wrong. 4. We get 23.75. Well, because if you said 95 over 4, because we're picking test points, so you're picking numbers in between, remember? So would you know offhand exactly what number to pick? Yeah.
So we're gonna be.
It's one of those rare occasions of mine where I actually look for the decimal, because normally I am totally cool with 95 over 4.
So we're gonna be meeting a calculator.
Yeah.
Yeah, that's what he said.
Oh no.
Okay. So we already know nothing works below -5/4 because I have to pick numbers bigger than that or I get an imaginary number. Few people are not paying attention. Albert, a couple of times now today. Okay. I have to pick a number bigger than -5/4 because if I don't, I'll get an imaginary number under here, and that will never work out. So this one, I'm greater than that. I'm not checking a test point under there. Anybody have any questions on that one concept?
Re-say that.
Sure. Let me restate it, and then I'll let you type it. Okay. So right here, what's underneath my even root must be greater than or equal to 0. Don't listen to him. I'm the one talking at you. He's mumbling.
No, I was gonna say, can you like tap on the screen so we know where we're pointing at for the video?
No. Trigger your memory. Pay attention. I don't do it on purpose. So this underneath the even root needs to be greater than or equal to 0, because if it's not, I have the square root of an imaginary. Don't want that. Or actually, the square root will give me an imaginary. I apologize. Okay? So I know my values for x have to be greater than or equal to -5/4, no matter what. So therefore, to the left of -5/4, none of those are solutions. That's it.
Why did we need the 23.75?
Because of the fact that I need to know, because this is an inequality, so I will have a range of solutions. Maybe 3 is a solution, and 4, and 5, and 6, and 7, and 8, and 9, 10, right? Or maybe everything past 23.75. Maybe. Sure, it's -1.25. All right, so we pick something between these and see if it works. All right, so x is between -5/4 and 23.75. Right, so what do you pick? 0. What's is the square root of 5 less than or equal to 10? Yes. Sure. So let's and there's a lot of verbal there, not a lot of. One second. All right. So I'll add a little bit to the chart. So the first area I'm checking is this area right here between -5/4 and 23.75. Aiden said 0. Sorry, x equals 0. That would be in that area. Was it Albert? Sorry, Albert. Albert said x equals 0. Everybody okay? 0 is between these? So if I check 0, I get the square root of 5 is less than or equal to 10. That's true. So this is one of my solutions if I have multiple. Since when I plugged in 0, I got a true statement, that is one of my solutions. Now I've got to do greater than 23.75. 24. Huh? or 25. Okay? So, ladies, you stopped paying attention? Yes. Okay? I'm accusing you, and that is all there is to it. So we pick something greater than, we pick x equals 24. And we get 4 times 24, which is 96, plus 5. We get the square root of 101 is less than or equal to 10. And that's false. So the only solution is between negative 5/4 and 23.75. Lucas.
We don't have to show math past like the square root of 101 is less than or equal to, right? Because
We know that the square root of 100 is 10, so the square root of 101 must be greater than 10. Yeah, you're good there. So, you guys are going to have the next 17 minutes to work on this. Work on it, please. Tomorrow, I'm just going over 3 examples in Desmos. And then after that, it'll be time to start reviewing for the Chapter 4 test. Wednesday will be 100% review. And then Thursday will be the test. We've got them back there getting ready to go. So I'm hoping to get them done today.